Hello everyone, welcome to this episode of Universion's Airplane, Newton's and Bernoulli principle. So, while I was wandering in nature, I asked the question how we can fly on our planet. And what I found based on Newton's and Bernoulli principle is that we have to have this simple image in our mind in order to understand how we can fly again in our planet. So while I was under the tree, something interesting happened. I did ask an AI, what do you think about this? And I get some interesting answers. So you see, the first AI that I asked gave me this kind of answer, which is pretty close to reality. The other one that I asked also gave me some pretty close to reality picture, but you see, again, with some simple arguments, they are not able to convey what you have, and you need to ask them way a lot to answer clearly. The last one that I asked gave some more interesting result, and you see here, he managed to do quite a good job. But then, seriously, I would like to ask a scientist how we can think about Newton's and Bernoulli principle and what would this scientist would answer. So he asked Sir Isaac Newton, what do you think about it? And he answered, well, my third law says for every action there is an equal and opposite reaction. And so imagine me as an oblate plane, then if I have a force which is applied downward, then an upward force will appear. Okay, sir, but then it will just remain either on the ground or in the sky. How we can launch it? This is the interesting question. And then Bernoulli appeared and he said, I know, let's create a wing that creates strong air pressure below while low pressure above. So what? Consider air particle motions, matter, forces, acceleration, gravity, height, area, velocity, pressure, density under calculus. Oh, so the particles that move above the wing due to its shape move faster to reach the end point than the particles moving below the wing. And so what, Bernoulli? Oh, neglecting height changes, this creates a high pressure on the bottom and a low pressure on the top, which creates a positive upward net lift force, which makes the plane launched. Amazing, let's see it in practice. So, Bernoulli thought about a lot of mathematics and he concludes this kind of law, which basically you can neglect the height changes and you have to assume pressure, density and velocity that are constant according to this rule. And this implies that, you see, we have the conservation of Bernoulli principle that says when velocity is low, pressure is high. So let's create a wing. Cool. So here is a wing, and this wing has to have some thrust. When this thrust happens, there is a flow that comes from above with velocity up and pressure up. And high velocity flow means low pressure, while from below you have low velocity flow and high pressure. And what does this result to? According to the law, there is a net lift force which is proportional to half the density of the differences of velocities from up and down quadratic times the area A. Okay, that's all good, but can I think it in more rigorous way? And of course, my child Bernoulli replied, and here are the math. Okay, and a shorter one? Well, here. So, pause here to practice the math. They are very, very interesting. I encourage you. Now, I asked what would the singer say, and she replied. So, with this episode, I hope I convey the basic rules of Newton's and Bernoulli principle in order to construct safely an airplane. Keep imagining, guys.
Whoa, be careful! Awesome landing! Ta-da!
Thank you. Subscribe for more.